Thank you for your kind words. It is our pleasure to be able to help others. We are glad that our efforts have been of assistance. We understand that finding answers to electrical questions can be time-consuming and frustrating. That is why we are committed to providing quick and accurate information to our readers. We are happy to know that we have been able to make a difference. We wish you all the best in your future endeavors. Electrical engineering involves the design, development, testing, and supervision of the manufacturing of electrical equipment. This equipment includes electric motors, machinery controls, lighting, wiring in buildings, radar and navigation systems, communication systems, and electric power generation, control, and transmission devices. Electrical engineers work in a wide range of industries including research, development, design, testing, and manufacturing. They may specialize in areas such as power systems, control systems, instrumentation, communications, or computer engineering. Power systems engineers design and develop systems for generating, transmitting, and distributing electrical power. They work on projects such as power plants, transmission lines, and distribution networks. Control systems engineers design and develop systems that control the operation of machines and processes. They work on projects such as automated manufacturing systems, robotic systems, and aircraft control systems. Instrumentation engineers design and develop systems that measure and control physical quantities such as temperature, pressure, and flow. They work on projects such as process control systems, medical devices, and scientific instruments. Communications engineers design and develop systems that transmit and receive information. They work on projects such as cellular phone networks, satellite communication systems, and internet networks. Computer engineers design and develop computer hardware and software systems. They work on projects such as embedded systems, computer networks, and operating systems. Electrical engineering is a challenging and rewarding field. Electrical engineers play a vital role in our society by designing and developing the electrical systems that power our world. Some specific areas that electrical engineers might focus on include renewable energy systems. This involves the design and implementation of systems that generate electricity from renewable sources such as solar, wind, and hydropower. Smart grids, which are advanced electrical grids that use digital technology to improve efficiency, reliability, and security. Electric vehicles, which involve the design and development of electric vehicles and their charging infrastructure. Robotics, which is the design and development of robots for various applications such as manufacturing, healthcare, and exploration. Internet of Things, often abbreviated IoT, and this involves the design and development of interconnected devices and systems. Signal processing, which is the analysis and manipulation of signals such as audio, video, and data. Control theory, which is the mathematical framework for designing and analyzing control systems. Electromagnetics, which is the study of electromagnetic fields and their interaction with matter. Microelectronics, which is the design and fabrication of microchips and integrated circuits. Electrical safety, which is the design and implementation of safety measures to prevent electrical hazards. Codes and standards such as the National Electrical Code, often abbreviated NEC, which is a set of standards for the safe installation of electrical wiring and equipment. Grounding and bonding, which are techniques used to prevent electrical shock and fire hazards. Circuit protection, which involves the use of fuses, circuit breakers, and other devices to protect electrical circuits from overcurrents. Arc flash hazards, which are dangerous electrical explosions that could occur when electrical equipment fails. Personal protective equipment, often abbreviated PPE, which is clothing and equipment worn by electrical workers to protect them from electrical hazards. Lockout-tagout, which is a procedure used to prevent accidental energization of electrical equipment during maintenance. Test equipment, which is used to measure electrical quantities such as voltage, current, and resistance. Troubleshooting, which is the process of identifying and repairing electrical problems. Electrical codes and standards are a set of rules and regulations that govern the safe installation and maintenance of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, often abbreviated NFPA, and the Institute of Electrical and Electronics Engineers, often abbreviated IEE. The purpose of electrical codes and standards is to protect people and property from electrical hazards. These codes and standards cover a wide range of topics including wiring methods, overcurrent protection, grounding, and bonding. The National Electrical Code, often abbreviated NEC, is the most widely adopted electrical code in the United States. The NEC is updated every 3 years and is based on the latest safety standards. The NEC covers all aspects of electrical installations from the service entrance to the individual outlets. The NEC also includes requirements for special occupancies such as hazardous locations and healthcare facilities. In addition to the NEC, there are other electrical codes and standards that may be applicable depending on the location and type of installation. These codes and standards may be developed by state or local governments or by industry organizations. It is important to be familiar with the applicable electrical codes and standards before beginning any electrical work. Failure to comply with these codes and standards can result in serious injury or property damage. Grounding and bonding are two important safety measures that are used to protect people and property from electrical hazards. Grounding is the process of connecting an electrical system to the earth. This provides a path for fault current to flow back to the source, which will cause the circuit breaker to trip and de-energize the circuit. Bonding is the process of connecting all of the metal parts of an electrical system together. This creates a low impedance path for fault current to flow, which will help to prevent electrical shock. Grounding and bonding are required by the NEC for all electrical systems. The NEC specifies the types of grounding and bonding conductors that must be used, as well as the methods for installing them. It is important to follow the NEC requirements for grounding and bonding to ensure the safety of people and property. Circuit protection is the use of devices to protect electrical circuits from overcurrents. Overcurrents can be caused by short circuits, overloads, or ground faults. If an overcurrent is not interrupted quickly, it can cause damage to the electrical system or even start a fire. There are two main types of circuit protection devices: fuses and circuit breakers. Fuses are one-time devices that melt when an overcurrent flows through them. Circuit breakers are reusable devices that trip when an overcurrent flows through them. Fuses and circuit breakers are rated in amps. The amp rating of a fuse or circuit breaker is the amount of current that it can carry without tripping. It is important to select the correct amp rating for a fuse or circuit breaker to protect the circuit from overcurrents. The NEC specifies the amp ratings for fuses and circuit breakers that must be used in different types of circuits. It is important to follow the NEC requirements for circuit protection to ensure the safety of people and property. Arc flash is a dangerous electrical explosion that can occur when electrical equipment fails. Arc flashes can produce temperatures of up to 35,000 degrees Fahrenheit, which is hotter than the surface of the sun. Arc flashes can also produce a blast wave that can cause serious injury or death. Arc flash hazards are present in all electrical systems, but they are more common in high voltage systems. Arc flash hazards can be reduced by using proper safety procedures and equipment. Some of the safety procedures that can be used to reduce arc flash hazards include energizing electrical equipment before working on it, using insulated tools and equipment, and wearing personal protective equipment. Personal protective equipment, often abbreviated PPE, is clothing and equipment worn by electrical workers to protect them from electrical hazards. PPE can include items such as safety glasses, gloves, boots, and arc-rated clothing. The type of PPE that is required will depend on the type of electrical work that is being performed. It is important to wear the correct PPE to protect yourself from electrical hazards. Lockout-tagout is a procedure used to prevent accidental energization of electrical equipment during maintenance. Lockout-tagout involves disconnecting the equipment from its power source and then attaching a lock and tag to the disconnect switch. The lock and tag prevent the equipment from being accidentally turned on while it is being worked on. Lockout-tagout is required by OSHA for all electrical work. It is important to follow the lockout-tagout procedures to prevent accidental energization of electrical equipment. Test equipment is used to measure electrical quantities such as voltage, current, and resistance. Test equipment can be used to troubleshoot electrical problems and to verify that electrical equipment is working properly. Some of the common types of test equipment include voltmeters, ammeters, ohmmeters, and multimeters. Voltmeters are used to measure voltage. Ammeters are used to measure current. Ohmmeters are used to measure resistance. Multimeters are used to measure voltage, current, and resistance. It is important to use the correct test equipment and to follow the manufacturer's instructions when using test equipment. Troubleshooting is the process of identifying and repairing electrical problems. Troubleshooting can be a challenging task, but it is essential for maintaining the safe and reliable operation of electrical systems. Some of the common steps involved in troubleshooting include gathering information, isolating the problem, testing the components, and repairing the problem. When troubleshooting an electrical problem, it is important to start by gathering information about the problem. This may include talking to the person who reported the problem, looking at the electrical drawings, and inspecting the equipment. Once you have gathered enough information, you can start to isolate the problem. This may involve using test equipment to measure voltage, current, and resistance. Once you have isolated the problem, you can start to test the components. This may involve using a multimeter to check the continuity of wires or to test the operation of switches and relays. Once you have tested the components, you can start to repair the problem. This may involve replacing a faulty component, repairing a broken wire, or tightening a loose connection. Electrical safety is a critical aspect of electrical engineering and should be prioritized in all electrical work. Here are some essential electrical safety tips. Firstly, always de-energize circuits before working on them. This is the most important safety rule. Always turn off the power at the circuit breaker or fuse box before working on any electrical circuit. Secondly, use insulated tools. Insulated tools will protect you from electrical shock. Make sure that the insulation on your tools is in good condition and that there are no cracks or breaks. Thirdly, wear appropriate personal protective equipment, often abbreviated PPE. This may include safety glasses, gloves, and shoes. Fourthly, never work in wet conditions. Water is a conductor of electricity, so you should never work on electrical circuits in wet conditions. Fifthly, be aware of your surroundings. Be aware of the location of power lines and other electrical hazards. Sixthly, never overload circuits. Overloading a circuit can cause a fire. Make sure that you are not using more electricity than the circuit is designed to handle. Seventhly, use ground fault circuit interrupters, often abbreviated GFCIs. GFCIs can protect you from electrical shock by detecting ground faults and interrupting the circuit. Eighthly, inspect electrical cords and plugs regularly. Make sure that the cords are not frayed or damaged and that the plugs are properly grounded. Ninthly, never run electrical cords under rugs or carpets. This can damage the cords and create a fire hazard. Tenthly, keep electrical equipment away from flammable materials. Electrical equipment can generate heat, so it should be kept away from flammable materials such as paper, cloth, and gasoline. 11thly, if you are not comfortable working on electrical circuits, call a qualified electrician. Electrical work can be dangerous, so it is important to call a qualified electrician if you are not comfortable doing the work yourself. These are just a few electrical safety tips. By following these tips, you can help to prevent electrical accidents and injuries. Here are some additional details on how to handle specific situations. Firstly, dealing with exposed wiring. If you encounter exposed wiring, do not touch it. Call a qualified electrician to repair the wiring. Keep others away from the area until the repairs are completed. Secondly, responding to electrical shocks. If someone is experiencing an electrical shock, do not touch them directly. Turn off the power at the circuit breaker or fuse box. Once the power is off, you can safely touch the person and provide first aid. Call for emergency medical assistance immediately. Thirdly, handling electrical fires. If there is an electrical fire, Do not use water to put it out. Water is a conductor of electricity and can make the fire worse. Use a fire extinguisher that is specifically designed for electrical fires. Call the fire department immediately. Fourthly, using extension cords safely. Use extension cords only when necessary. Choose extension cords that are the correct gauge for the amount of electricity you will be using. Do not overload extension cords. Do not run extension cords under rugs or carpets. Inspect extension cords regularly for damage. Fifthly, maintaining electrical panels. Keep electrical panels clean and free of obstructions. Label all circuits clearly. Do not store anything in front of electrical panels. Schedule regular inspections of electrical panels by a qualified electrician. Sixthly, recognizing signs of electrical problems. Be aware of signs that indicate potential electrical problems, such as flickering lights, frequently tripping circuit breakers, burning smells, or sparking outlets. If you notice any of these signs, have the electrical system inspected by a qualified electrician promptly. Seventhly, following local electrical codes. Be sure to comply with all local electrical codes and regulations. These codes are designed to ensure the safety of electrical installations. Consult with local authorities or a qualified electrician to understand the specific requirements in your area. Remember that electrical safety is an ongoing responsibility. Stay informed about potential hazards and best practices to protect yourself and others from electrical accidents. Regular inspections, proper maintenance, and adherence to safety guidelines are essential for a safe electrical environment. These points cover several crucial aspects of electrical engineering, safety, and maintenance.